Prepare to have your mind blown. Jupiter's volcanic moon Io might be way hotter than anyone ever imagined. But here's where it gets controversial. This discovery could challenge everything we thought we knew about its mysterious subsurface. Using data from NASA's Juno spacecraft, scientists have uncovered that Io, the solar system's most volcanically active body, is emitting hundreds of times more heat than previously estimated. And this isn't just a small oversight, it's a game-changer for understanding this fiery moon. The surprising twist? This massive underestimation wasn't due to a lack of data but rather how that data was interpreted. And this is the part most people miss. Nearly half of Io's heat comes from just 17 out of its 266 known volcanic sources. This concentrated heat distribution, rather than a uniform emission, suggests that the long-theorized Io-wide lava lake beneath its surface might not exist after all. But don't take this as the final word, it's a hotly debated topic that's far from settled. Federico Tosi, team leader from the National Institute for Astrophysics, NAF, explains that recent studies have focused on Io's heat emissions in the infrared spectrum to determine if a global magma ocean lies beneath. However, when comparing Juno's data with detailed thermal models, something didn't add up. The thermal output values seemed too low compared to what we'd expect from known lava lakes, Tosi noted. This discrepancy led the team to rethink their approach entirely. Here's the kicker. Previous studies heavily relied on a specific infrared band called the M band, which is great for spotting the hottest volcanic regions but completely overlooks colder, more expansive areas. Tosi likens it to estimating a bonfire's brightness by only looking at the flames and ignoring the glowing embers. You're missing the full picture, he warns. This oversight led to vastly underestimated heat calculations. By reanalyzing Juno's data, the team discovered that Io's volcanoes aren't uniformly hot. Instead, they feature a scorching outer ring surrounding a cooler, solid central crust. While this central region appears dim in the M band, it covers a much larger area, emitting enormous amounts of heat that were previously ignored. When this hidden heat is factored in, the total heat flux skyrockets, up to hundreds of times higher than earlier estimates. This shifts our understanding of Io's energy balance and raises questions about its subsurface magma ocean. But here's the catch: while this research challenges the magma ocean theory, it doesn't completely rule it out. We're not saying it doesn't exist, but it can't be confirmed by these observations, Tosi clarifies. This cautious approach highlights the complexity of the issue and the limitations of current data. Unfortunately, we might not get another close look at Io anytime soon. Juno's recent observations were the most detailed ever, but its orbit won't allow for such close passes again. Future missions like ESA's JUICE and NASA's Europa Clipper will focus on other moons, leaving Io's secrets largely unexplored, for now. Despite this, monitoring Io remains critical. The team's findings provide a new framework for interpreting even remote observations, bringing us closer to understanding its extreme volcanism. This could shape future missions dedicated to Io, Tosi says, finally revealing what fuels the solar system's most intense volcanic activity. Now, here's the controversial question: does Io's concentrated heat distribution truly rule out a global magma ocean, or are we missing something fundamental? Let's hear your thoughts in the comments. Do you think this fiery moon still hides a subsurface ocean of magma, or is that theory up in flames? The team's groundbreaking research was published on November 5 in Frontiers in Astronomy and Space Sciences. For more mind-bending space discoveries, stay tuned to the latest updates on rocket launches, skywatching events, and beyond.